So the next graph type we're going to be looking at are histograms. Now, a histogram looks a lot like a bar graph, but there is a very subtle yet important distinction between a bar graph and a histogram. First of all, a bar graph often shows categorical data, meaning that each bar represents a category or an item. Like if I were to say, what are your favorite colors, and I were to be doing a survey of that, everyone who votes for their favorite color being blue, it would be then that many votes within the bar that represents the color blue, and then another one that would be the color red, yellow, green, and so on and so forth. Whereas in a histogram, the bars represent numeric values, and those numeric values are not just a singular value, but a range of values. And that range, you can think of it like buckets, like anything that falls within this and that range would go into that bucket. So let's use our heart rate data again as our example. So let's say this was one cohort's worth of heart rate data in beats per minute. I then would take that raw data and I would put it into a data table. And that data table, I would put each one as an interval. I would say anything that falls between, let's say, 40 and 50, and then the number of times that happens, I would put in the frequency section. So any numbers that falls within 40 and 50, I would then do a little tally. Then I would go through and I would put it with the same range of intervals. So this would be 10 beats per minute as the interval range, the next 10, and then the next 10, 60 to 70 beats per minute, and then 70 to 80 beats per minute, and lastly 80 to 90 beats per minute. Now, notice that sometimes the interval, it starts and ends on the same number. That's just to show that there are no gaps within it. So these bars are actually going to be touching one another when we see them all lined up. But let's say we actually were to have one value that was exactly 50, it would go into the higher interval, the next bucket up. So this one, you can really think of it as 40 to 49.9999999, and this one is 50 to 59.99999. If it's exactly 60, it would go into the next bucket. All right, so now I would go through and check all of my data values. So anything that is in the 40s, I'm going to put here. So I'm going to find each one of those. So there's 1, 2, 3. It looks like just 3. So I'm going to do a tally, 1, 2, 3. And I'm going to double check to make sure I didn't miss any. Yep. So the frequency of that was 3 times. And I'm going to go to my next interval, 50 to 60. So anything in the 50s, that's 1 time. There's another time. Another. Oh, yep. 1, 2, 3, 4. 4 times. Okay, now I'm going to go to my next interval, 60 to 70. So let's go ahead and scan. 1 time, 2 times, 3, 4, 5. Yep, I think that's it, 5 times. And then 70 to 80. Okay, that's 1 time, 2 time. There we go, and I think that's it. So that only occurred twice. And then my last interval, 80 to 90, I can see that happened just 1 time. So the frequency of that occurring was just once. Okay, so let's do a few definitions here. Feel free to pause while you write this down. So this is just a little reminder here. So each interval contains data from the lower boundary up to, but not including the upper boundary. So even though it says 40 to 50 is the interval range, if there were to be a data value that's exactly 50, it would go into this bucket, like I said. And then we want to use tallies to keep track of data converting to numbers. All right, so the